Hello everyone, this is Abhishek KV. Welcome to my YouTube channel. I hope you are all studying well. Yes, last class we completed the second chapter, inverse trigonometric functions, right? And that completes the first two chapters of your class 12. The first chapter is relations and functions and the second chapter is inverse trigonometric functions. As you all know, the first chapter, relations and functions, is the continuation part of introduction of relations and functions, which you are all already studied in your class 11. And the second chapter, inverse trigonometric functions, is also the continuation part of trigonometric function, which is also you are all already studied in your class 11. And in this session, I move on to the next chapter, that is chapter 3, called matrices. This is not the continuation part, because this is the very new chapter for you people, and in this chapter we are going to learn the definition of matrix, then types of matrices. Here, matrix is a single matrix and matrices is one or more, that is plural, this is singular, which we discuss later. And then operations of matrices, that is addition of matrices, subtraction of matrices, multiplication of matrices. Then the transpose of a matrices. Using this definition, we are going to define another important types, that is symmetric and skew symmetric matrix and skew symmetric matrix. Then we are going to learn the invertible matrices. This is by using invertible of a matrix can be studying by using elementary row and column. Operation. So these are the main subtopics which we are going to study in our chapter 3. Definition of matrix, types of matrices, operation of matrices, transpose of a matrix, and from this we define symmetric and skew symmetric. And the last subtopic is invertible matrix. This is by using elementary row and column operation. And in this chapter, for your annual examination, you will get totally 9 marks. One question for 1 mark, one question for 3 mark, and one question for 5 mark. Totally it is a 9 marks package. And remember, this is not only important for these 9 marks. Matrices is the important tool to learn the next chapter called determinant. Okay, and let us start this session with the definition of matrices. What is matrix? See, definition says a matrix is a ordered rectangular array of numbers or functions. See, a matrix is a ordered rectangular array of numbers or functions. For example, see, this is the rectangular array. If this rectangular array contains what? Numbers or functions. See, it may be 1 or 100 or functions. It is sin theta or sin inverse theta cos theta, or it may be 1000, or it may be 1 by 2, 4, or x. X is also variable, right? So a matrix is a ordered rectangular array of numbers or functions. As you all know, this is horizontal and this is vertical, right? See, this line is called horizontal line and this line is called vertical line. In matrices, this horizontal lines are called rows. These horizontal lines are called rows and this vertical lines is called column. It's called column. Sir, what is that? See, this is the horizontal row. This is the horizontal and this is called row. This is also horizontal. This is also horizontal. Then the question arises, sir, where is vertical? See, this is vertical. This is vertical, this is vertical. Therefore, the horizontal order is called rows, the vertical order is called column. Therefore, if a matrix has m rows and n column, then it is called order of matrix m into n. See, if a matrix has m rows, that is horizontal, and n columns, that is vertical, then that matrix is called order of a matrix of order what? M cross n. M cross n is the word m into n. This is read as m by n. M into n can be read as m by n. See, here in this, if I consider this matrix, that is 1 sin theta x y cos inverse theta y z 2 3. See, if a matrix has m rows, how many rows we have? See, 1 row, 2 row, 3 row. That is, a matrix has 3 rows and n columns. How many columns we have? See, 1, 2, 3. 1, 2, 3. 3 columns. 3 columns. Therefore, this particular matrix is a order of matrix what? This is m by n. This is read as m into n. This is the product sign. M into n can be read as what? M by n. This is what? 3 by 3. That is 3 into 3. This is equal to what? Of order 3 cross 3. If the examiner asks how many elements you have, m into n, that is m by n, that is 3 by 3, that is 9 elements. See, a matrix is a ordered rectangular array of numbers or functions. If a matrix has m rows and n columns, then that matrix is called order of a matrix of order what? Order of a matrix of order m by n. This is 3 by 3. See, if I consider this matrix 1, 2, 3, 4, rectangular array of numbers or functions. These are all the numbers. It is what? 2 by 2. What is the order of this matrix? 2 by 2. How many elements? 2 into 2. This is 1, 2, 3, 4. This is equal to 4 elements. And inside this rectangular array is called elements of a matrix. And this matrix is represented by capital letters in alphabets. See, this is the main matrix A and these are the elements of a matrix. Of order what? 2 cross 2. So this is the main introduction about the matrices. You should know what is matrix and what is the order of the matrix. Then the next question is, see, I told you, if I consider this matrix A is equal to 1, 2, 3, 4, 1, 2, 3, 4, this matrix of order what? 2 by 2, that is totally 4 elements, and this element 1 is denoted by A11, that is A suffix 11. This 1 represents row, that is this first suffix represents rows, number of rows, and this second suffix represent number of columns. See, the element of first row, first column. Then A12, that is, it is in first row only, but if I consider the column, where it is? Second column, see, first row, second column, first row, second column. Similarly, 3, that is A, see, this is first row, this is second row, which column? First column. Then this, it is still in second row, but first column, this is in second column. See, the beauty of mathematics. See, first row, second row, first column, second column. This is the first row, first column element, the element of first row, first column. If the examiner asks what is A11, what is A11 in matrix A, then your answer should be what? A11 is equal to 1. That is the element of first row, first column. I told you, please remember this. The first suffix represent row. The first suffix represent row and the second suffix represent column. It is not possible first column, first row. You should read the first row, first column, the element of first row, first column. If the examiner asks what is A12 element, then you should realize the first row. See, this is the first row, second column, this is first row, this is second row, this is first column, and this is second column. Therefore, first row, second column. See, first row, this is first column, second column. It is in, therefore, the element is 2. Therefore, see, this is for 2 cross 2 matrix. What about this? See, if I consider 1, 2, 3, 4, 5, 6 represented by capital letter. Therefore, these are called elements. See, this is A11, A12, A21, A22, A31, A32. This is of the form. See, first row, first element 1, first row, second element 4, second row, first element 2, second row, second element 5, third row, first element 1, third row, see, this is 2, right? Third row, second column 6. See, therefore, if the examiner asks, write the element of A31. See, I already told you the first suffix represents row, third row. See, first row, second row, third row, first column. Third row, first column is 3. Third row, first column is, see, then A22. See, second row, this is first row, second row, third row. Then this is first column, second column, second row, second column, this is equal to 5. If the examiner asks A23, second row, third column, it is not possible. It is not possible to write because we have only two rows, first row, second row. There is no third column. Therefore, this question does not exist. This question does not exist. So, this is how we are going to learn what is matrix and what is order of matrix. From that order of matrix, we represent, this is the first row, first column, first row, second column. First row, second row, first column, second row, second column. Third row, first column, third row, second column. See, if, therefore, if matrix has m rows and n columns, that is called the order of the matrix. The general form of m cross n matrix is of the following. See, it is denoted by A11, A12, up to. See, this is row, first row. So, it should be 1, 1, 1, 1. But if I consider like this, first column, second column, up to, how many columns we have? N columns, A1n, then A21, A22, up to A2n, 2, 2, 2, because the first suffix represents rows. First row, second row, then A31, A32, up to A3n, like this. How many rows? We have m rows. M rows. See, we have m. First suffix represents rows. This still in first column. See, this is first column 1, 1, 1. Second column 2, 2, 2. But first row 1, 1, 1. Second row 2, 2, 2. Like this. Therefore, am1, am2 up to A. If the matrix has m rows, n column, then it is the order of matrix m by n. M by n. That is mn. That is mn. This is what? M by n. This is the matrix, the general form of matrix m by n. I hope you are all getting this. Suppose if the examiner asks, the question, construct 2 cross 1. Construct 2 cross 1 matrix. 2 cross 1 matrix whose elements is given by Aij is equal to I plus j. Aij is equal to I plus j. See, first we should consider the question, analyzing the question first. 2 cross 1 matrix. I already told you, first number represents row, second number represents column. See, if I consider the matrix, how many rows? 2 rows. 1, 2. How many columns? Only 1. Therefore, the matrix is of the form A11, A21. First row, first column. Second row, first column. But 1, 2 cross 1. 2 rows, 1 column. Only 1 column. The matrix is of the form A11, A21. Given what? Given Aij is equal to I plus j. Aij is equal to I plus j. What we want? We want A11, right? A11. This is equal to what? 1 plus 1. See, instead of I and j, what I have? 1, 1. First row, first column. That is I1, J1. This is equal to what? 2. Then A21. What is A21? See, second row, first column. I is equal to 2, J is equal to 1. This is equal to 3. Therefore, matrix A is given by 2, 3. For the given condition, Aij is equal to I plus j. Aij is equal to I plus j. This is of Aij. What is I? 1 less than or equal to I less than or equal to how many rows? I represent rows. M rows. What is j? 1 less than or equal to j less than or equal to n. See, j represents column 1 to n. 1 to, see, first column, second column up to n. First row, m row. M row. First row, m row. Therefore, suppose if the examiner give, this is the first question, whose elements. Second question, Aij. Instead of 2 cross 1, if examiner give, construct 3 cross 3 matrix whose elements is given by Aij is equal to I by j. Aij is equal to I by j. First we should consider 3 cross 3 matrix. How? See, which is of the form? See, consider A of 3 cross 3. It is of the form A11, A12, A13. We should stop A13. We should stop at A13 because this is first row. But this is first number represents rows, second number represents columns. Therefore, first row, first column, first row, second column, first row, third column. If I write A14, this is not exist because we have only 3 columns. So we should stop here. Therefore, then A21, A22, A23, A31, A32, A33. See, the matrix is of the form like this by using the elements. See, Aij is equal to I by j. We need to find A11, A12, A13. See, A11 is equal to, instead of I and j, we have 1 and 1. Therefore, 1 by 1. What is 1 by 1? 1. Therefore, this is equal to what? 1. And A12, first row, second column. This is equal to 1 by 2. I is equal to 1, j is equal to 2. This is equal to 1 by 2. Similarly, A13, 1 by 3, 1 by 3. Similarly, A21, 2 by 1, 2. This is 2 by 2, 1, 2 by 3. This is 3 by 1, 3, 3 by 2, 3 by 2. What is 3 by 3? 1. See, the matrix, a rectangular array of numbers are function, but this matrix contains all the elements as numbers. So this is the possible question examiner like to ask. Suppose if the examiner asks if the matrix has 8 elements, if the matrix has 8 elements, what are the possible order? What are the possible order it has? See, if the matrix has m rows, n column, then it is the order of the matrix m by n. If the matrix has 8 elements, what are the possible orders? See, it is of the it may have the order 1 by 8 or 8 by 1. It may 2 by 4 or 4 by 2. It may has 3 ones are 3, 3 twos are 6, 3 6 are 8. Multiples of 3 does not contain 8. Then 2 cross 2, 3, 4. We already write 4 into 2. 8 cross 1. See, these are the possible orders. If you multiply this, you should get 8 because it has 8 elements. 1 into 8, 8 into 1. That is 1 row, 8 columns, but it has 8 row, 1 column. 2 rows, 4 columns, 4 rows, 2 columns. These are the 4 possible orders if the matrix has 8 elements. What about if the matrix has 13 elements? 1 into 13, 13 into 1. These are the only 2 possibilities because 13 is a prime number. 1 row, 13 column, 13 row, 1 column. So these are the possible questions you may getting for 1 mark. You should learn what is matrix and order of matrix. From that, these are the possible orders. Yes. Next, we move on to the first subtopic of your chapter 3, that is types of matrices. See, row matrix, column matrix, square matrix, diagonal matrix, scalar matrix, identity matrix, zero matrix, equality of matrices. These are all the types of matrices. See, what is row matrix? A matrix is said to be a row matrix if it has only one row. See, if I consider this matrix row, it is in horizontal line. 1, 2, 3. don't worry about the columns. A matrix is said to be a row matrix if it has only one row. See, one row, but column 1, 2, 3. I already told you, don't worry about the columns. A matrix is said to be a row matrix if it has only one row. What is the order of this matrix? First we should write row, number of rows, one row, 1 by how many columns? 1, 2, 3. See, a matrix has only one row, therefore it is row matrix. Similarly, column matrix. A matrix is said to be a column matrix if it has only one column. See, if I write root 3, 1.224, root 3, 1.224. The horizontal lines are called rows and the vertical line is called column. It has only one vertical line, that is only one column. What is the order of this matrix? It is not 1 cross 3 because we should write the row, number of rows first. What is the number of rows here? Number of rows 1, 2, 3, 3 cross 1. See, if it has only one column, then it is called column matrix. If it has only one row, then it is called row matrix. Only one row, then it is called row matrix. Then square matrix. If the matrix has same number of rows and columns, that is number of rows is equal to number of columns. Number of rows is equal to number of columns. If the matrix has number of rows is equal to the number of columns, therefore that matrix is nothing but, this is the row matrix, then that matrix is nothing but square matrix. So these are all the definition, very important for your annual examination. Examiner may ask what is row matrix, or what is square matrix, or what is column matrix. See, these are all very important definition. You should remember this, okay? You should understand, okay? A matrix has equal number of rows and columns. That is, number of rows is equal to number of columns. Then that matrix is called square matrix. My question is if I consider this as A is a square matrix? Answer is no, because number of rows 1, number of columns 3, 1 not equal to 3, therefore it is not square matrix. Is matrix B is a square matrix? Again no, because number of rows 3, number of columns 1, 3 not equal to 1, therefore number of rows is not equal to number of columns, therefore that matrix is not a square matrix. If I consider the matrix 1, 2, 3, 4, see, number of rows 2, number of columns 2, this is by 2 by 2, number of rows is equal to number of columns, therefore this is what? It is a square matrix. It is square matrix of order 2. Therefore if I consider 1, 4, 5, root 3, root 2, 1, 4, x, y. See, 1, 2, 3, 3 rows, 1, 2, 3, 3 columns. This is the square matrix of order 3. This is the square matrix of order 3. Number of rows is equal to number of columns. I hope you are all getting this. Then I move on to the diagonal matrix. Define diagonal matrix. You should start the definition. A square matrix is said to be diagonal matrix. See, for row matrix, a matrix is said to be a row matrix if it has only one row. A matrix is said to be a column matrix if it has only one column. A matrix is said to be a square matrix if number of rows is equal to number of columns. But to define diagonal matrix, we should need the square matrix. What is square matrix? Number of rows is equal to number of columns. Therefore, your definition should be a square matrix. You should start the definition like this. That is, to define diagonal matrix, we should need the square matrix. That is, we should need the number of rows is equal to number of columns. Therefore, a square matrix is said to be diagonal elements. A square matrix is said to be diagonal matrix if all its non-diagonal elements are equal to are equal to 0. See, my question is it a diagonal matrix? No. A square matrix, yes, it is a square matrix. It is said to be a diagonal matrix if all its non-diagonal elements are equal to 0. See, if I consider this matrix A 0 0 0, B 0 0 0, Z. See, this is what diagonal elements, right? If I consider this parallelogram, this is diagonal, this is anti-diagonal. Therefore, if you consider the matrix rectangular array, this is diagonal, this is anti-diagonal. All the elements are non-diagonal. What the definition says? A square matrix is said to be a diagonal matrix if all its non-diagonal elements are equal to 0. All its non-diagonal elements are equal to 0. But diagonal elements A, B, C, this is not equal to 0. So this type of matrix is said to be a diagonal matrix. Then I move on to scalar matrix. See, to define scalar matrix, we should need the diagonal matrix. That is, a diagonal matrix is said to be a scalar matrix if all its diagonal elements are same. All its diagonal elements are same. See, my question is, this is diagonal matrix because all its non-diagonal elements are equal to 0. Is it a scalar matrix? No, because the definition says all diagonal elements are same. That is, all diagonal elements have equal elements are functions. See, if I consider this A 0 0 0 A 0 0 0 A. See, all its diagonal elements are equal. Therefore, this is called the scalar matrix. But this is not scalar matrix. It is a diagonal matrix. To define scalar matrix, we should need what? We should need square matrix. To define scalar matrix, we should need diagonal matrix. Diagonal matrix is a square matrix. All its non-diagonal elements are equal to 0. Therefore, its diagonal matrix is said to be a scalar matrix. Diagonal elements means all its non-diagonal elements are equal to 0. If all the diagonal elements are equal, then that is called the scalar matrix. Then I move on to identity matrix. What is identity matrix? See, a square matrix equal number of rows and columns is said to be identity matrix if all its diagonal elements are equal to 1. All its diagonal elements are equal to 1 and rest of all elements are equal to 0. Why? To define the identity matrix, all diagonal elements are equal to 1. Rest of all elements means non-diagonal elements. Therefore, we can also state the definition of identity matrix as a diagonal matrix is said to be a identity matrix if all its diagonal elements are equal to 1. See, all its diagonal elements. If you start the definition from square matrix, we should say all diagonal elements are equal to 1 with rest of all elements are equal to 0. If you start the definition from diagonal matrix, then diagonal matrix means all non-diagonal elements are equal to 0. Diagonal elements should be equal to 1, then only we say that matrix is called identity matrix. For example, if I consider 1 0 0 0 1 0 0 0 1. See, all diagonal elements are equal to 1. Therefore, this is what? Identity matrix. Is it a scalar matrix? Yes. Every identity matrix is a scalar matrix, but every scalar matrix need not be identity matrix. Right? If I consider A, it is a scalar matrix, but it is not identity matrix because all diagonal elements are equal to 1. But if I consider this matrix, this is diagonal matrix, all diagonal elements are equal to 0. This is scalar matrix, same. This is also identity matrix. I hope you are all getting this. Then I move on to zero matrix. If the matrix, every element of matrix is equal to 0, then that matrix is said to be a zero matrix, and that value is equal to 0. Is it clear? If every element of, see, if I consider 2 cross 2, 0, 0, 0, 0, this is also a zero matrix. This is also a zero matrix. Yes? So these are all about the types of matrices. Then I consider the equality of matrices. We will definitely get in the question from this equality of matrices. Equality of matrices means we should need two matrices. A matrix, let A is equal to matrix of order ij and B is equal to of elements small letters bij. A is said to be equal to matrix B. That is, matrix A is said to be equal to matrix B. The first condition, order of both A and B should be equal. Order of both matrix A and B should be equal. Every element of A, the second condition is every element of matrix A is equal to, every element of matrix A is equal to corresponding element of matrix B. Consider two matrices A and B of same order, m cross n. This should be in same order. Remember, A is said to be equal to B. The first condition is order of both matrix A and B should be equal. Every element of A is equal to corresponding element of B. See, if I consider 3, 0, 0 or 4, 5. This is equal to 3, 0, 4, 5. Is these two equal? Yes. Order of matrix 2 cross 2. First condition over. Every element of A. See, first row, first column element 3 of matrix A is equal to first row, first column element of matrix B. First row, second column element of matrix A is equal to first row, second column element of matrix B. Second row, first column, second row, first column. 5 is equal to 5, 4 is equal to 4, 0 is equal to 0, 3 is equal to 3. Therefore, if I consider 2, 0, 3, 4, is this equal? Yes, it satisfies the first condition. Same order, but 2 is equal to 2. Is it 3? 0 is equal to 3? No, therefore, this is not equality of matrix. I hope you are all getting this. So, from this, examiner asked the question like this. Examiner asked the question as if x plus 3, z plus 4, 2y minus 7, minus 6, a minus 1, 0, b minus 3, minus 21, 0. This is equal to 0, 6, 3y minus 2, minus 6, minus 3, 2c plus 2, 2b plus 4, minus 21, 0. If this matrix is equal to that matrix, find the values. Find the values of A, B, C, X, Y, Z. See, X plus 3. See, first to define the equality of matrix, we should need the same order. See, this is of order 3 by 3. This is also of order 3 by 3. First condition holds. each element of A is equal to the corresponding element. First row first element of the first matrix is equal to, first row first column of the first matrix is equal to the first row first column of the second matrix. Therefore x plus 3 is equal to what? 0. X plus 3 is equal to 0. Therefore what is the value of x? They are only given. These are equal. That's why we consider x plus 3 is equal to 0. X is equal to minus 3. If I consider z plus 4 is equal to 6. See, second row second column is equal to the second row second column. Therefore what is z? 6 minus 4. This is equal to, z is equal to 2. X is equal to minus 3. Similarly, first row third column, that is 2y minus 7. This is equal to what? 3y minus 2. 3y minus 2. See, 3y, if I consider minus 2 to the LHS, then it becomes plus 2 minus 7. This is equal to 3y minus 2y. This is equal to minus 5 is equal to y. X is equal to minus 3, z is equal to 2, y is equal to minus 5. Similarly, b minus 3 is equal to 2b plus 4. Then we are getting b. A minus 1 is equal to minus 3. Then we are getting a. Equating, yes, that's all. 0 is equal to 2c plus 2, then we are getting c. I left that work to you only. I hope you are all getting these types of matrix and especially the equality. You should getting the question from equality of matrix. So these are the possible subtopics to get 1 mark. You should know the definition of matrix, order of matrix, types of matrix, then lastly equality of matrix. These are the 4 possible subtopics to get 1 marks, and this is not only important for 1 marks. These are the basic tool to study the next subtopics in matrices. Okay, thank you.